Hey guys, welcome back. So today we are working on another SAT question, and this question says, 3 parallel lines in a plane are intersected by a fourth line, forming 12 angles. If one of the angles has measure 28 degrees, how many of the other 11 angles have measure 28 degrees? So the first thing I went ahead and did is draw up the problem. My lines, I apologize, are not perfectly parallel, but just pretend that these 3 lines here are in fact parallel. And the other thing I did was I drew a fourth line intersecting it, which is also called a transversal, and then I gave one of the angles a measure of 28 degrees. So in order to solve this problem, we have to think back to geometry a little bit and remember our angle relationships. So the first thing that jumps out at me is that this angle here, I'm going to use a different color for that, this angle here is vertical to this angle here. And vertical angles are congruent. So that tells us that this angle also has a measure of 28 degrees. Now, what does this angle have a measure of? This angle is going to have a measure of 180 degrees minus 28 degrees. And that's because these two form a linear pair. And linear pairs always add up to equal 180 degrees. So we can go ahead and figure that out just for the heck of it. Let's see, minus 28. 2, 5, 1. So this angle is going to have a measure of 152 degrees. So I'm going to write that out in red so that we don't count it. And this measure here is also going to be 152 degrees because, again, those are vertical. So now let's jump over to these 4 angles here. What do we know? One thing we know is that same side interior angles add up to equal 180. So in that case, you would have this angle here and this angle here. Those are going to add up to equal 180. So that means that this is also going to be 152 degrees. We can use the same logic to tell us that this angle here is going to be equal to 28 degrees. And this is going to be equal to 28. This is going to be equal to 152. Moving over, we can use the same exact logic, and that will tell us that this is 28, this is 28, this is 152, and this is 152. So there are so many different ways to solve this problem. I actually had a bit of a trouble with, which order to go in, but the thing I would recommend if you had any trouble is go back and review your angle relationships. So go back and review alternate interior or exterior angles, and in that case, alternate interior, alternate here, that refers to which side of the transversal it's on. So we have, let's say this is the right side of the transversal and this is the left side of the transversal. So alternate means that one is on the right and one is on the left. It doesn't have to be alternate. If they're on the same side, generally they are referred to as same side, interior, or exterior, but I've also seen them referred to as corresponding interior, exterior. I was taught same side, it doesn't matter, it's just a different term, but the idea is that it means that they're on the same side of the transversal. So in that case, let's say a same side interior would be, let's say 28 and 152, this angle here and this angle here. These are same side interior because they're both on the right side of the transversal, and they're called interior because they're inside of these parallel lines. So the second part, the interior exterior, refers to the angle's position to the parallel lines. So in that case, let's say if it's inside here, this would be interior, and this out here would be exterior. Because you imagine these lines is kind of like a cutoff. So anything on the inside is interior, anything on the outside is exterior. So I think I mentioned vertical angles. Is there anything else I'm missing? Oh, corresponding angles. So corresponding angles are a little bit harder to remember, but they're not too bad. So corresponding angles would be this 28 here and this 28 here. So corresponding are on the same side of the transversal, but one is on the inside and one is on the outside. So this one here is interior, but this one here is exterior. This 152 and this 152, those are also corresponding because again, one's on the outside, one's on the inside, but they're on the same side. So I hope that was helpful. If you did have any trouble, again, I'm sorry, I forgot to actually answer the question. So to actually answer the question, how many of the other 11 angles have a measure of 28 degrees? So we started out with this one, so we're not going to count that. But going from there, we have this one. So we have 1, 2, 3, 4, 5. So we have 5 other angles with a measure of 28 degrees. So sorry if that video was a little bit all over the place, but again, if you did have any trouble, I recommend going back to your geometry and reviewing alternate interior angles, corresponding angles, same side interior and exterior, and vertical angles. My email will be in the description box if you have any additional questions, and I am a math tutor if you need any one-on-one help over Skype. So if you did find this video at all helpful, please like and subscribe to my page. All right, thank you so much for watching.